Hi, welcome to another EC&M Tech Talk. And today we're going to talk about this new requirement that you've heard about before, especially here on Tech Talks, but it's the NFPA 70B requirement that says we have to do electrical maintenance. Today we're going to keep it practical. We're going to talk about 5 different topics when it comes to electrical maintenance. We're going to talk about the requirement and the enforcement procedures that we can expect to see when it comes to this requirement to perform electrical maintenance on our equipment. And then we want to get into the nitty-gritty of it. How to do this, how to put this together to make sure that we comply. So we're going to go into how to build the equipment list. And then the next step that you would have to do is, well, once I've got my list of equipment, what equipment do I have to do maintenance on? How often do I have to do maintenance on it? And that's going to take us right into topic number 4. And topic number 4, we're going to look at an example of where we perform some electrical equipment maintenance. We're just going to use a dry type transformer. And then finally, the last topic we get into then is, well, okay, now I know what equipment I have to maintain, how often I have to maintain it, and some general information about the maintenance requirements. But specifically, where can I find that information that tells me what procedures I have to perform, what tests I have to perform, and so forth. So that's our 5 topics that we're going to talk about today. So first, let's move into the requirements and enforcement of this new NFPA 70B standard. The NFPA 70B standard became effective in January of 2023, as you may recall from previous Tech Talks. Now, there's no, as I even said back then, there's no 70B police, right, that are going to go out and enforce this document. I think where we're going to see the enforcement is just like in the NFPA 70E standard, which is the standard for our electrical safety requirements in the workplace. So if you think about that, how does OSHA enforce 70E? Well, they use 70E. It's that ANSI-approved reference document, right? Consensus standard. So they can cite the NFPA 70E standard in their enforcement. The same is true with NFPA 70B. I think that the way we're going to end up seeing 70B enforced, and of course hopefully it never is, but if there is an incident, and if maintenance had been done on that equipment, and that if that maintenance had been done, then there's a good chance that incident would never have happened, then I think that's where we're going to see 70B come into play in enforcement activities, right? We have a consensus standard that tells us how to do business, that tells us how to maintain our equipment, and if something happens, something goes wrong, we have that incident, then we have to answer as to why we weren't complying with some type of standard of performing maintenance. And of course, the most obvious and easiest, rather than to reinvent the wheel, as I say, is to use that NFPA 70B standard. So that's my thoughts as far as requirements and enforcement. Now, do you have to follow the NFPA 70B standard? No, there's nothing written down that says you shall follow NFPA 70B. It is simply a standard, that consensus standard then, that can provide us guidance on how to perform our electrical maintenance in order to comply with our OSHA requirements to where we have a workplace that is essentially free from recognized hazards, as the General Duty Clause says. One of the first things we're going to have to do then is we move into topic 2 now. So topic 2 is talking about how do we get started. One of the first things we have to do is we have to build an equipment list. Now, you all may already have something at your facility called an asset list. I don't care what size or type facility you have. You could be a local contractor with just some equipment in your shop, and you think about it, if you're leasing vehicles or you own vehicles, trucks and so forth, right, you're already doing maintenance on that equipment. You've already got a maintenance schedule. You get the oil changed every so often. You rotate the tires every so often, most likely, and you've got a schedule for that, right? So it's no different. And why? Because for 2 reasons. Number 1 is you want to keep the equipment safe. Surely that's important, especially like tires and brakes and so forth. But also, it's money, right? It's a business decision as well to maintain our equipment. So the same is true when it comes to our electrical equipment. And it's very likely that if you're in a larger facility, manufacturing, industrial, oil and gas, mining, whatever, you already have an asset list. which is a list of your equipment and tells you when it was purchased and how much it was purchased for and who from. And then it can go into more details about the specific of that equipment, when it was put into service, what it's used for, what's the maintenance history on it, and so forth. Quite often, you're probably going to have, if you're in a larger facility like that, you're going to have some type of software program, right? One of the more popular computer software programs that's maybe company-wide, organization-wide, or whatever, that where you maintain all of that equipment, plus a lot of other information and data as well. So take a look at that. If you've got your asset list already built, a list of equipment, great. The next thing we're going to have to do is analyze it. So whether you have to go out in the field and take a look at that equipment and make a list of it, talk to people or whatever, but things like, what are you going to want to keep records of when it comes to that equipment? Well, what conditions it is in. Is it an important piece of equipment to us? Do we have spare parts on hand? Where do we get spare parts? What types of maintenance do we do? All types of equipment. We need to know its size and ratings, nameplate data. The more information that we have in our records, the more intelligent we're going to be when it comes to a maintenance, isn't it? Okay? So we need to organize all of that data. Anymore, we typically do that with software, and there are plenty of programs out there that can help you with that. Several options are available. You have to decide, your company has to decide what's best for your company then. Let's move to topic number 3 then. Once we have our list of equipment, the next question might be, well, do we have to do maintenance on all equipment? No, probably not. Okay, there's some things we probably that we really won't do maintenance on. We might run it till it fails. But what equipment do we have to do maintenance on then? And then how often should we do the maintenance? And then we'll get into specifically what maintenance we must do. So the first thing we have to do is, after we get our equipment list, is assess our equipment. Now, it works out easier, doesn't it, if we can assign a number? Like, let's look at a piece of equipment and say, well, that equipment condition is either a 1, 2, or a 3. Maybe if it's a number 1, it's in good shape, it's like new equipment, good physical condition, it's in a perfectly good environment, no harsh chemicals around it or anything like that, and it's, whatever, as far as its criticality, for business purposes, it's important, but we could live without it for a little while or whatever. Safety-wise, it's fine. It's not going to hurt anybody if it fails. So we might assign a number, 1, 2, or 3 to that piece of equipment. And then we're going to use that, what we call that equipment condition, 1, 2, or 3. And I'm going to tell you how to do that in a little bit more detail here. But once we assign that condition 1, 2, or 3, then we can go look at a list which is provided not only in NFPA 70B, but I'm going to give you another important resource as well. And that's the International Electrical Testing Association. The International Electrical Testing Association, and they can be found at netaworld.org, also provides a ANSI-approved standard for equipment maintenance of electrical equipment. And in that standard, you will also find a list, just like you will in 70B, of all different types, all of our different types, in fact, of electrical equipment, and how often we should do what types of maintenance on it. But whether I use the NFPA 70B standard or the NETA standard, it still boils down to the same thing. I have to look at the physical condition of my equipment, the criticality of that equipment, and its operating environment. From there, I can assess and then come up with what I call the equipment condition, and then I can determine how often I have to do my work on it. So generally speaking, as we assign these numbers 1 or 2 means like, well, probably the equipment's, really good shape, or it's okay, or maybe we've missed a maintenance cycle on it or something like that. Whereas if it comes equipment condition number 3, that's the most critical. Like, boy, if that thing goes down, that's going to ruin this process, cost us a lot of money. Or, even more importantly, if that equipment fails, somebody could get hurt, righty? So 1, 2, or 3 is what we're going to use. Now there's a table in the 70B standard then. So we're going to talk a little bit about the 70B, but do not forget about the NETA standards as well, as we call them, NETA, International Electrical Testing Association, right? So in the NFPA 70B, there's a table, 9.2.2, to help us determine the frequency of our equipment. So we're going to look at a little of that. I'll put some things up on the screen here as we go. First thing we want to determine then maybe is the physical condition of the equipment. So if we look at the equipment and say, hey, you know what? This equipment's just like new. In fact, we look at our asset list and it was just put into service 18 months ago or something like that, whatever. So in that case, if it's in really good shape, we think, subjective call, right? We think it's okay, it's like new equipment, we're going to assign it a physical condition of number 1. Now, if it's okay, but maybe we've realized over time, over the years as we've done maintenance, we should probably step up the maintenance requirements on this piece of equipment. It's getting older. We've looked at the data we've recorded on different tests, and we found out that, yeah, we should probably go ahead and step up the maintenance requirements. Or maybe we've missed the last cycle or two, something like that. We didn't get to do the maintenance on it real world, right? And so, okay, now we're going to assign it a condition 2, physical condition 2. So 1 is like new, 2 is okay, but yeah, we still need to step up the maintenance. Now, number 3 is where the equipment is not operating like it should. It's not performing up to its specs. We need to really, do more maintenance on this. Maybe even think about ordering a spare or something like that. It's starting to age on us to the point where we need to start thinking about replacement. So in that case, we're not ready to throw the equipment out yet. Let's just assign it a physical condition number 3 and do maintenance on it a little bit more often. So that's for physical condition, 1, 2, or 3. Then we look at the criticality of the equipment. So we look at business factors, priorities, downtime, uptime, all of those type things, right? And we determine how important this equipment is to us. Assign it a 1, 2, or 3. If it is a 3, that means that the equipment failure could result in an injury to someone. In that case, it's definitely a 3. We'd want to really want to increase the amount of maintenance we do on it. And by the way, we're always going to follow manufacturer's instructions, okay? All this information we're going through today, it's always going to tell us in 70B, follow manufacturer's instructions. So they're going to supersede 70B. But now, if you know, right, from reading your O&M manuals, when it says follow manufacturer's instructions, there's often not a lot of detail in there that you would need. The operating environment is the third thing. So physical condition, criticality, what's the operating environment? 1 or 2, hey, we're in a great environment, there's no real problems here, so maybe we give it a 1. Number 2, temperatures get pretty warm in here. Sometimes it becomes an issue for us, whatever. Maybe we give it an operating environment of 2. Operating environment 3, harsh environment. Chemicals, vapors in the area, whatever. We could be getting some corrosion problems, things like that. We need to step up our maintenance requirements. So now we've looked at 3 areas, haven't we? We've looked at physical condition, we've looked at criticality, and we've looked at the operating environment. In each one of those 3 areas, we assigned a number, either 1, 2, or 3. So now we take the highest number. We just look at the overall, what we evaluated, and if the highest was a number 3, bingo. Now we go to the next matrix that I'm going to show you here in just a second, and it's going to tell us how often to do the maintenance on that equipment. So we take the highest number that we come up with of physical condition, criticality, or operating environment, and we're going to go to a table. Now, let's move to topic number 4 and look at an example. We're going to talk about a dry type transformer. So we've got a dry type transformer that sits over here on the floor, and it supplies a panel board. We need to assess that equipment. 3 things we're going to look at: physical condition, criticality, and operating environment. we look at the physical condition. Hey, that transformer is pretty much almost like new condition, but it's been in service for a while, but it's doing good. I look at all the maintenance data on it. Looks like it's been pretty good shape, insulation resistance and so forth. However, we did miss the last maintenance cycle on it, and so I'm going to go ahead, instead of assigning it a 1, I'm going to assign it a 2. We're going to step up the maintenance on it a little bit. And the operating environment is clean. I look around, hey, clean, dry area, no temperature considerations, no chemicals, no vapors, no harsh environment, no moisture, whatever. So I decided to give it an operating environment condition of number 1. Good, clean area. So I've got physical condition of 2, operating environment of 1. Now I look at the criticality of this piece of equipment. Hey, it supplies a panel board over here. And we decide that, from the business standpoint, we talk to the operations folks, or they're talking to us and they're trying to decide too. And we decide that, what? If we lose that transformer, money-wise, it's really not that bad. We don't have any processes that we're going to lose that are going to cost us a lot of money. And, we decide, hey, we can replace that transformer fairly easily. We can get another one, or maybe we've got a spare in the warehouse or something like that. And so normally we might assign it a 1 or 2 as far as criticality. However, we take a look at that panel board that transformer is supplying, and there's a ventilation fan on there in the lab area. And that ventilation fan, well, what it does, it sucks some bad gases out of the laboratory that appear once in a while. And so it is possible that that ventilation fan did fail. Someone's safety, health and safety could be affected in that lab area. So we decide, the company, you, whoever, decides we're going to assign it a criticality of 3. Why? Because if it fails, it might affect the health and safety of someone. So that's the highest number. So when we look at it, at this transformer, we've assigned it a number 2 for physical condition. We've assigned it a number 1 as far as its operating environment. And for criticality, because of its safety issue, we gave it a number 3. Therefore, when we go to do the maintenance, we're going to do the maintenance in accordance with condition 3. That's our highest number. So let's take a look. This is generally what we do when it comes to maintenance, right? We do visual inspection, we do cleaning, lubrication we're not going to do on a transformer, I don't think. And then we do some mechanical servicing, and we run some electrical tests. If my equipment falls in condition number 1, then I have to do my visual inspections every 12 months. Every 12 months if it's condition 2. If it's condition 3, because this transformer does fall under equipment condition 3, it says I've got to do my visual inspection every 6 months. Okay? And so this is right out of 70B. You'll also find similar information in our maintenance test specifications from NETA as well. As far as cleaning, you can see the numbers. Every 60 months, 36 months, or 12 months, depending on whether it's condition 1, 2, or 3. And then take a look at that electrical testing. If it's condition 1, if it's in great shape, environment's fine, it's not a critical piece of equipment, I've only got to run my electrical test every 5 years, every 6 months. If it were condition 2, it would be every 36 months. But because our equipment condition came out as a number 3, due to that criticality, then it says every 12 months we have to do our electrical testing on that piece of equipment. So that's how we determine the frequency for our electrical equipment. We determine its physical condition, we determine its criticality, we determine its operating environment, we take the highest of the numbers, 1, 2, or 3, and we take that to our table for equipment condition assessment on how often we do our maintenance, or how often we go out and perform maintenance on the equipment then. And then finally, the last topic number 5, is the maintenance items. What is it specifically that you want me to do, boss? We've determined we're going to do electrical tests on this transformer every 12 months now because we can't afford to lose that ventilation fan. Well, first thing, the boss is going to tell me what? Always follow manufacturer's instructions, right? And so certainly we're going to do that. Now, we've got to, and also very important, we need to maintain this data as we go along. We need to keep it organized, put it into your computer, write it down, use a tablet, whatever it is you're doing in your facility, use that system to its fullest. Otherwise, plenty of horror stories out there about, oh, we just don't have good records. Don't want to be in that situation. No reason for that today. With a lot of work, granted, but we can get to the point where we do maintain good maintenance records then. Now, what should be in those maintenance records? Well, so we have what I call administrative info. When did we put the equipment into service? How old is it? And any other data. What did it cost? Certainly accounting's going to want to know that, right? So I want that basic information. Where is it located in the plant? What is it fed from? How about nameplate information? Definitely nameplate information I need as part of my maintenance requirements then to maintain my data for maintenance requirements. I also want to keep in mind in my written procedures, because I'm going to use written procedures to do my maintenance. Why? Because I'm a human being and I'm going to make a mistake and I'm not going to be consistent. I'm going to have different people doing my maintenance at different times. So I need a written procedure, a written checklist in order to do my maintenance, inspection, servicing, and testing and record that data. I always want to do as found and as left tests. If I don't know what good I've been doing, right, with my maintenance. And then I want to record all my inspection and test data. Now, once again, whether you're using 70B, maintenance test specifications, manufacturer's instructions certainly has the priority, whatever it is, you'll go out and you perform that maintenance and you have a written procedure for it. So typically on the transformer, you might doing things, or you will be doing things like visual and mechanical inspections. What are you testing? Transformer turns ratio tests would be a very common test. Almost always we're going to do insulation resistance testing, right? Because that insulation is going to be one of the first things that fails. We've covered that in previous tech talks. Plenty of information out there on insulation resistance testing. And grounding and bonding on your transformers is very important. So you'll want to check terminations and connections, take measurements if need be or whatever, and make sure that you have proper grounding and bonding. Now, 70B identifies really three fundamental tests that we should go ahead and always perform. First off, qualified persons, right? Qualified persons, meaning people have to be trained, knowledgeable in the construction and operation of that equipment if they're going to go ahead and do maintenance. And so what are these three areas that we must do maintenance on? We have to do maintenance on bolted connections, our terminations and connectors inside of that transformer. We have to do insulation resistance testing on the windings in that transformer. And also a third fundamental test says that we should be doing things like infrared thermography, right? Even with a small infrared camera like this, whatever you have. And you may well be, doing your infrared thermography every year. So that's excellent. When it comes to checking your bolted connections, there are three methods that 70B is going to say, hey, use one of these three. Either go ahead and get a torque wrench screwdriver calibrated right, verify your torque connections, measure the contact resistance with a low resistance ohm meter, or use that infrared camera. And while the equipment's operating, know what you're doing with infrared surveys, go ahead and you can do an infrared survey to check for the tightness of bolted connections. Insulation resistance quality, insulation resistance testing, we've got to be sure we're consistent there, that everybody's doing the spot reading test for 60 seconds. We're correcting for temperature as needed. If we're doing something like a polarization index, is whoever's doing that test, do you know how to interpret those readings and so forth? And then for infrared thermography, of course, we go ahead and, that takes special training, right? And we become certified as an infrared thermographer and produce a report on our equipment and so forth. But all of those three vital areas then, bolted connections, torque connections, connectors, and so forth. Insulation resistance quality is number 2, and infrared thermography are all recommended then. Now, finally then, a couple other quick tips. Make sure you know how to clean equipment. Follow your manufacturer's instructions as to how to clean it, whether it's compressed air, vacuuming first maybe, what types of solvents you can and cannot use on it, and so on. Service labels is a good idea. It's I believe an informative annex in 70B. I'm required by 70E when I walk up to a piece of equipment to determine its condition of maintenance. Has this piece of equipment, has this motor or circuit breaker, whatever the heck it is here, has it been serviced in the last certain amount of time? Is its maintenance up to date? If there's a little label on that piece of equipment or disconnect or control panel or MCC bucket, whatever it is, that says next service due date, and I fall with before that next service due date, right? If my next service due date is 6 months from now, I know my equipment has been maintained. If I'm past that next service due date, we did miss that maintenance schedule on that piece of equipment, and so it may no longer meet that requirements for a proper condition of maintenance before I perform normal operation and servicing in that equipment. So keep those little service labels in mind. I like those. Make sure all of your one-line diagrams, arc flash studies, everything are up to date, coordination studies and so forth. Keep your drawings up to date, redline them in the field if you have to, and when you can, you get engineering updates on them. And finally, once again, make sure that qualified people are performing your electrical maintenance and that you're following all your rules in your NFPA 70E standard, your electrical safety work program then. So that's it in a nutshell for putting together and complying with your electrical maintenance program, all righty? Make sure you do it, make sure you be safe, and we'll see you at the next Tech Talk.